All right, so this is the final video to explain the last section here. So we're going to look at the conclusion and the discussion in this video. So I'm going to create a new page here, and I'm going to write conclusion. And in our conclusion, we should state what the relationship is first. The relationship between the period of oscillation of the cantilever and the mass on the end is a square root relationship governed by the equation. And here's our equation. I'm just going to cut and paste that. And given that that took so much effort, I'm going to make it centered on its own line. Okay. According to theory, the equation should be, and I'll press Alt-I, Oops, I must have just done something here. An equation. So Alt-I and then E is a quick way to get to equation editor. The equation should be T is equal to 2 times pi times square root. And what was it again? It was, let's have a look here. Oops, on this sheet. 2 pi square root ml cubed over 3ei. Oops. Let's get rid of this thing. What was it? ml cubed. To get to the superscript, you just do Shift-6, so that little hat-looking thing. In fact, divided by. In fact, what I might do is write this as a fraction. I'll show you how to do that. So you write / frac, and then I don't need this bracket either. And then I write ml, not squared, cubed, and then divided by, and to get to the bottom of this, so I'm just pushing the forward cursor. So if I go forward, 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 I get to the bottom. And then this was 3ei. Okay, and just to make it look nicer, I'm going to get rid of that times because I don't really want it there. Okay. This equation, which can be rewritten as T is equal to 2 pi times SQR, whoops, / SQRT / FRAC, and that's L, and I'll explain what I'm doing here, L cubed over 3ei times, oops, I don't want that, I want that out of there, times. Okay, and the reason I've rewritten it like this is so that I can easily compare this equation with my experimental one. So this stuff here should be equal to this. So 2 pi times the length that I used cubed, or the square root of the length that I used cubed, divided by 3 times the flexural rigidity of my ruler should be equal to 0.8 if this theory is consistent with my experiment. Because this stuff here is just a number times square root m. And in my experiment, I found that there was just a number times square root m for the relationship as well. My equation here, the theoretical equation, says there should be no y-intercept. I have a y-intercept, so that's something I'm going to have to discuss in my discussion. Okay? So this means that the gradient should be equal to and we'll stick this in, and I'll just copy and paste this stuff. Copy, and then paste that here. In my experiment, L was 0.8 meters, and according to the notes provided, EI was approximately 7. This means that the gradient is, or should be, this is according to theory, equal to I'll write it out, i.e. 2 pi times square root of fraction, and my length was 0.80 cubed over 3 times 7. And if we compute what that is, we get, this calculator is quite annoying in how it works, but I'm going to use it anyway. And so this should be 2 times pi times, and then I need to bracket here, bracket 0.8, and then I want to cube this, and then divide by 21. And then I want to square root everything in that bracket, and that gives me a final answer of 0.981. This so my experimental gradient was, well, that's this thing here. So the theoretical gradient is not within the uncertainty, or does not, we can say, does not lie within the uncertainty of my experimental gradient. I will discuss this later. Furthermore, theory predicts a 0 y-intercept. The y-intercept, but y-intercept in my experiment was this stuff here. Oops. So I will also examine where this discrepancy comes from. Okay, so it's important that we note that. So in theory, the gradient should have been 0.981. In experiment, the gradient was only 0.8. In theory, the y-intercept should be 0, but in experiment, my y-intercept was 0.08 plus or minus 0.04. So 0 does not lie within that, and 0.98 does not lie within this one. So there are some issues to discuss, which is not necessarily a bad thing. It just means that there are some things that we didn't take into account in our experiment.